Hello, everyone. Let's continue with working with linear inequalities. So consider this part two. Yesterday we discussed what linear inequalities are. We provided some, we worked out some examples, and then we got to graphing these linear inequalities. So let's do some more examples on graphing these linear inequalities to get some more practice on getting these done. So as always, there is a process in working with these inequalities or equations, right? But in this situation, it specifically says inequalities, which is similar to working with linear equations, with the exception that instead of an equal sign, we now have an inequality symbol. So there is the process, right? Linear inequalities, steps one, two, and three. The first step would be is to change the inequality into the form of sloped intercept. So you would typically have basically solving for y. We have y on the left. On the right side of the inequality symbol, we have mx plus b, where m is your slope and b is your y-intercept. Now, when you're solving for y, make sure you take into account the when you're working with negatives, right? So be sure to flip the inequality. If you happen to multiply or divide by a negative, you're going to flip that inequality symbol. Once you begin the graph, well, you need to take into account whether you have a less than or greater than, or if it's less than or equal to, or the greater than or equal to. It'll be a dashed line if it doesn't have the equal sign, right? So it's just less than or greater than. It'll be a solid line if it does include the equals, right? So less than or equal to and the greater than or equal to, that indicates that it is a solid line. And then the last step would be because it is an inequality, which part of this graph are we shading? Are we going to shade above or, to the right of the line if when it's greater than or if it says greater than or equal to? We're going to shade below the line or to the left if it says less than or less than or equal to. So let's take a look at example number two, where we have y is greater than or equal to negative 4x. Well, it has the y by itself there, so that's great. It's already in the form of slope intercept, so we don't have to worry about that. So now we take a look at the inequality symbol. This says greater than or equal to. So the first thing to do would be to determine whether or not this is going to be a solid line or a dashed line. Because it has the equals on there, this indicates a solid line, right? Solid line. Now, which part are we going to shade? Are we going to shade above or below this line? Well, this says greater than, right? So let's see, greater than or equal to, it says to shade above. So we are going to shade above. So let's get to graphing. All right, so this says negative 4x. Is there a b? So it should be mx plus b, right? Well, if there is no b, that just indicates that it's 0, right? There is no y-intercept, um, where it should say the y-intercept is 0. It's going to cross that y-axis at 0. So mx plus b. If b is 0, you typically don't write 0 for the sake of writing it, right? So it's 4x plus 0, b is 0. The y-intercept crosses at the origin. Okay, now let's look at the slope. The slope says negative 4. So m is equal to negative 4 over 1, right? So you're going to go 4 down, 1 across. But also, I want you to keep in mind that when we're graphing these extra points, you just need 2 points to draw a line, but to be more accurate, sometimes you want to do 3. So when you're graphing these points, negative 4 means negative 4 over 1, but it also means 4 over negative 1, right? These are equivalent. It's the same thing. Negative 4 over 1 or 4 over negative 1, it's still negative 4 over 1, right? Negative the fraction 4 over 1. So let's take a look at this one. So negative 4 means that we're going to go 4 down. So here you have 1, 2, 3, 4, and then it says 1 across. Okay, so this way. So here we have our other point. But what if I apply the negative on the bottom? Well, that just means that I'm going to go 4 up. So 1, 2, 3, 4, and then negative 1, meaning I'm going to go to the left instead of the right. So here is my third point. Cool. So now I have 3 points. So let me go ahead and draw the line. Since it is a solid line, I can do the shape. And I can simply go from here through there. Cool. All right. So which part are we going to shade? So I'm gonna just actually I'm gonna extend this a little bit. So this said I'm gonna shade above, right? So I'm gonna shade above. That would be over here. So above would be to the positive end or to the right also. And there we have our graph. Cool. So that's another example. All right, let's take a look at number 3. Of course, this will be saved on there for you to continue. So let's take a look at number 3, though. Number 3 is interesting in the sense that it is not set up for you the way it's easier to graph, right? It says 5x plus 3y is less than or equal to 12. So the first step would be to, and again, if you need to pause and go back to the previous problem, by all means, go ahead. This is obviously recorded. So 5 plus 3y is less than or equal to 12. Well, this is not in the form of slope-intercept. So I need to rewrite this to solve for y. So first things first is let's get rid of this 5x from the left. So I'm going to subtract 5x on both sides. So I get 3y is less than or equal to negative 5x plus 12. I'm putting the x in front because I want it in the form of mx plus b. So now I want y by itself. Well, that means I have to divide each part of this by 3. So y is less than or equal to negative 5 over 3x plus 12 divided by 3, that's 4. Okay, so that is in the form of slope-intercept. Okay, so now let's take a look at this inequality. This says less than or equal to. So is this going to be a dashed line or a solid line? Well, let's go back. It does include the equal, so that indicates solid. So I'm going to write solid. Okay, well, what about the shading? Am I going to shade above or below? Well, less than or equal to. Okay. Less than or equal to for the shading. Okay, so the less than or equal to, it says to shade below. So I'm just going to write below. Okay. So let's go ahead and graph, right? This is what we're graphing right here. Y-intercept is at 4. Okay. So 1, 2, 3, 4. So this is my y-intercept. Look at the slope, right? So m is equal to negative 5 over 3. Once again, negative 5 over 3. Well, that's the same thing as 5 over negative 3. So I'm showing you this just so that you can see when you're finding another point on that line is that you can go either to the right or to the left, right? Depending on where you put that negative. All right, so let's see. Negative 5 over 3, that's negative 5 down. So 1, 2, 3, 4, 5, and then 3 across. So 1, 2, 3. So my next point is right there. Now, what if I go 5 up and then 3 back, right? So this is positive 5. So, oh, it's too much. 1, 2, 3, 4, 5. Nope, I can't do that. Okay, well, let's go here. I'll do another point just for accuracy. 1, 2, 3, 4, 5, and then 3 across. So 1, 2, 3. Here is my third point. It has the equals there, so it's going to be a solid line. So I'm going to go from here through those points. Good to go. Now, what about the shading? The shading said that we're going to shade below. Okay, so I'm going to go to markup and I'm just going to shade below. That's it. We have graphed the line. We've shaded the appropriate part. We put it in the form of slope intercept. All 3 steps are complete. Okay, let's see. Let's work on the word problem. So let's talk about Stephanie here. Stephanie, we're looking at the old school data plans for messaging. So when I had my first cell phones back in the 90s, yeah, you got charged for everything. You got charged per minute that you were on. You got charged for each text message. And then eventually when we were able to message, images, pictures, memes, yeah, you get charged per image that you sent. So it wasn't unlimited like it is now. So this is what we're referring to, right? So here we have Stephanie. She says that she spends 10 cents for every text message that she sends, and she's charged 25 cents for every picture message that she sends on her mobile. Well, her budget is $30, right? So she can't spend more than $30. So let's see what we have here. It says here that we have 10 cents per text message, 25 cents per picture message, and her budget is $30 a month. Okay, so in these situations, you want to identify your variables, right? Because it says we need to write a linear inequality to represent this situation. Well, this is my x-axis, this is my y-axis. So if you were just calculating stuff, I'd recommend you use an appropriate variable, right? So it would be like T for text, P for picture. But I also don't want you to get confused when you're graphing this, right? Because we are graphing on the x-axis, we are graphing on the y-axis. So I'd suggest working with x and y as your variables. But if you're going to do that, you need to identify what each one is. So x is text. Oof, that's terrible. X is text, and y is going to be picture messages. Okay, cool. So what is it that we have? 10 cents per text, so 0.10 in decimal form per text. So 0.10x plus, well, 25 cents per picture message. So that's my y. Now it says her budget is $30, right? So that's the maximum amount that she can spend. She can't spend more than that. So when I add up the cost of all of the text messages and the cost of all of the picture messages, it can't exceed 30. Can it be below 30? Heck yeah. She'd want to save as much money as she can, but this is in reference to the inequality symbol. So she needs to spend less than or at most $30, right? So the inequality becomes less than or equal to. Okay. So let's go ahead and solve for y so that we can find the y-intercept. All right, so let's subtract the 0.10x from both sides. So we get 0.25y is less than or equal to negative 0.10x plus 30. Now we're solving for y, so let's divide by 0.25, divide by 0.25. Cool, so y is less than or equal to. Here's the tricky part. Because we're working with decimals here, it's a fraction. So if you divide this, you're going to get something like 2 0.4, I think it was. I think you get 0.4. So this is a slope though. We want the fraction, right? We want the fraction. So, well, let's figure this out. So obviously I know it's going to be negative. Well, look, we're talking about cents, right? So what I'm going to do is I'm just going to move the decimal over 2 times so that I'm working with 10 over 25. It's equivalent, it's a fraction. I did the same thing to both parts. So 10 over 25, well, they're both divisible by 5. So 5 times 2 is 10. 5 times 5 is 25. So that's my slope, negative 2 over 5, x. Now I have 30 divided by 0.25. Okay, that one, okay, I'm gonna have some difficulty there. So let's give it a go. 30 divided by 0.25. That's 120. So let's write that down. 120. So my equation is y is less than or sorry, my inequality is y or less is less than or equal to negative 2 over 5x plus 120. Okay. So I have converted this to slope-intercept form. I have my y-intercept, but it's 120. So I don't have, I can't use 1 unit or 1 box is equal to 1 unit because it's 120. So I have to find the appropriate scale. So let's do that. Let me see. So I got, I guess we can go 120. You can probably go like each square would be like 10. So 10, 20, 30, 40, 50, 60, 70, 80. 90, 100, 110, 120, 130, 140. So 140, 120, 100, 80, 60, 40, 20. Cool. And we'll need to use the same scale for the x-axis to make sure that it is a square, not something odd. So 20, 40, 60, 80, 100, 120, and 140. Okay, so let's graph that. So 120, that's my y-intercept. So that's right here. Now my slope is -2/5. I'm dealing with, h unit is 10, so 2/5, that's going to be too small for me to work on this. So let's increase that. So I'm going to add a 0 to the top and the bottom, right? Because -2/5, that's equal to -20/50, right? I just added a 0 or multiplied everything by 10. But if I do this, then it makes sense. I can, plot these without an issue. So -20/50, okay, so I'm going to go down 20, so -10, -20, and then I'll go to the right 50. So 1, 2, sorry, 10, 20, 30, 40, 50. So that's going to be right here. Down, let's go another point just to get 3. So down 10, 20, and then across 50. So 10, 20, 30, 40, 50. There we go. So let's draw our graph. But look, less than or equal to. I have an equals. That tells me that it's going to be solid. What about the area that I'm going to shade? Well, it says less than or equal to. So that's going to be the bottom. Okay, all I'm doing, I'm referencing our process. Okay, so let's draw. So shapes line because it is solid. So I'm going to go from here through these 2 points. There we go. And it says to shade the bottom. All right, so I'm going to just shade the bottom here. Cool. That's our graph. Okay, so let's see. Part B says using your graph, give 2 possible combinations of text and picture messages that she can send and stay within her budget. Well, what that's saying is, what combination of text and picture messages can she do and stay within the budget? So that basically cover any coordinate that is below that line, right? That's the whole purpose of the inequalities, is telling you which coordinates satisfy this inequality, and that can be any point. And so you decide, okay, what 2 points? So I got 40 here, so 40 text and 40 picture messages. That's within the shaded area. So I can simply write 40 texts plus 40 pictures. I can do 100 text and 80 picture messages. That's going to be right on the line, so that's still good. So 80 text plus 100 pictures. So these 2 coordinates satisfy the inequality. All right, so your homework assignment was, you were just doing number 1, 2, and 3 on the homework assignment. So make sure that you work on that. So let's take a look. The homework assignment is on linear inequalities. And let me just pull this up. So this is the homework assignment. You are just doing number 1, 2, and 3. So if you look at number 1, it's already in the form of y equals mx plus b. So you're good to go there. You're just going to, look at the inequality. What does that tell you? Is it going to be a solid line or a dashed line? Is it going to be shaded below or above? And then that's it for that one. But over here, it is not in the form of slope intercept. So you need to solve for y, but make sure that you're accounting for this multiplying or dividing by a negative, so that you know whether or not you're going to flip that inequality. Now for the word problem, the applications, that's giving some people some issues. So let me just discuss it for a little bit. It says here that in football, a kicker can score 1 point for the extra point on a touchdown or 3 points for a field goal. So Logan is the kicker for the high school team. The record of points scored by a kicker in one game is 24. It says here that Logan is hoping to beat his record in his next game. All right, so let's just take a look at the inequality in general, though. What does he want to do? Does he want to tie the record? Does he want to exceed the record, break that record, or does he want to be below that record? Well, the whole purpose of this is like he says that he wants to um, beat the record. So he doesn't want to tie it. So think about the inequality. Is it going to be less than, greater than, less than or equal to, or greater than or equal to? Keep in mind what he wants to do. He does not want to tie the record. He wants to break the record. Now, as far as your variables, you can keep it to the x and y, but you do need to identify what the x is equal to and what the y is equal to. So how does he get to 24 points, right? He's got to score points himself. So he's either got to kick a combination, he's got to kick some combination of extra points and regular field goals for 3. So some are worth 1, some are worth 3. When you add up both combinations, his goal is that it's going to be more than 24. Okay, so I've explained it in words. It's just a matter of writing down that inequality. So at this point, you should have an idea as to what your variables are going to be. Identify your x, identify your y, and then plug that in. And then once you do that, you're going to pick 2 combinations, like we just did on the example problem, that fit within or that satisfy the inequality. Okay, so it is not that difficult. It is a bit pretty much very similar to the example that we just worked on. All right, so should you have any questions, feel free to comment on the assignment or preferably comment on the assignment or shoot me an email. All right, thank you very much. Good luck to all of you. Make sure you submit this on time.